All right. Shh. Yesterday I think I did forget to mention I did forgot that you guys have very bad algebra. Um, so I want to talk about and actually I saw a cool question. I was helping somebody with algebra the other day. I was like, shit, I don't know how to do this, and I want to show you guys that. Let me see if I can find it though. Um, so yesterday we talked about things, but I forgot to mention to this arithmetic sequence. Did I spell right? Sequence. I just spell right? Okay, so arithmetic sequence is like this. It's like 9, 5, 4, 9, 5, not 1. I can't subtract. And -3, like this. Like that is the arithmetic sequence because they have a common difference. So the key word here is common difference. You learn this in algebra 2. You will learn common difference. Now, what is common difference? Well, common difference, they supposed to have the same thing. So let's just say if I have A3 minus A2, it should equal to A4 minus A3, and should equal to A5 minus A4. So they have the same difference. Usually the following term subtract prior term, and that's something that you need. There's a common difference. Now, actually, arithmetic sequence has a formula. It's an equal to a1 plus d times n minus 1. And that it was arithmetic sequence. You can actually plug in. You actually get d is a common difference, n is a term, a1 is the first term. You can find out any term you want. So that's arithmetic sequence. Got it? Okay. There is arithmetic series. A series is going to be 9 plus 5 plus 1 plus -3, dot, 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 dot. That's series. And the only difference between series and sequence is adding. You're adding each term. Okay? And if you want to find out all the term of this, there was an equation called partial sum. Here, if n over 2 times a1 plus a2, an. Do you have to use this in calculus? No, but I want to introduce you in algebra 2, like you learn about this. Have you seen this before? Well, Frederick Gauss, he was 7 years old. He invented this.
What a year. What a guy.
Yeah.
The story of adding up one.
Yeah, that's a story. There's a story that adding up from 1 to 100. So his teacher, he's just a very annoying kid, kind of like
Me.
kind of like Samuel. Okay, so Samuel just, I can imagine this too. Samuel was harassing the teachers, causing trouble, staying on the table, and then at the first grade, so shh, and then the teachers like kind of got pissed. I kind of had to give him some busy work. So it's like, Samuel, add from 1 all the way to 100, and then the Samuel come back to me like 30 seconds later or minute later, says, oh yeah, I got the answer, and they tell me the answer. And then what happened in this actual situation is the teacher actually didn't know what's 1 to 100 adding together, so he added by hand. And then you go add 1 plus 2 plus 3 plus 4 plus 5 plus 6 and all the way to 100. And so 20 minutes later, he got an answer, and then he checked with Samuel's answer, and he got the exact same answer. But how did he do it? Is using this formula, This formula is called, this is the first term, this is the last term, this is the term number. And how did he do it? So 1 plus 2 plus 3. Samuel, I cannot talk over you. Unless you want me to kick you out. All the way to 100. And what he did is added the first term and last term. So it'll be 1 plus 100. See that first term and last term? And then 2 plus 99. 3 plus 98. 4 plus 97. And keep on going. So total, there's a 50 sets of numbers. So 50 sets. Why is that 50 sets? Because if you have S 100, it's going to be 100 divided by 2. So that's 50. And the first term is 1. Last term is 100. So that's going to be 50 times 101. And so that's going to be 50, 50. So that's how you come up with the solutions. Now, this will work with any, it will work with this one too. Right? And if you don't believe me, just test the first 4 terms. You can actually s to the 4 for this particular case. Then I would get s of 4 is equal to, well, this 4 term divided by 2. And 9 plus -3. Right? Of course, this will work with 100 term as well. So I'll just work with first 4 term. So that would be 2 times what? That's equal to 12. And let's see if that's 12. 9 plus 5 is 14, 15. 15 minus 3 is 12. So it will work anything if you know the first term, if you know the last term, and if you know which term you want your series. Okay, so this is taught in Algebra 2. Now, if you don't know what the arithmetic sequence, this is also taught in Algebra 2. This is A1. D is a common difference. Now, term minus 1. Why is term minus 1? Well, here's the thing. Now, just imagine the situations right here. And this is a very, very easy situation. I decided to plant a tree at a, I planted a tree at a, let's say 12, at a 9-mile mark. Actually, at a 11-mile mark, right? And each tree, I have a difference of 3 miles, right? So that's going to be obviously 14, and that's equal to 17, I think, 20. If I didn't screw up my math. So then you say, okay, well, what's my mile mark at a 4th tree? Now, what's a 4th tree? Well, you have to start with the first tree, which is 11. That's where the A1 come in. That's the first term. And then D is a common difference, and there's 3 spaces. Why there are 3 spaces? Remember, I told you guys last year, if you have 4 trees, there was a 3 space in between. That's why you have n minus 1. Okay, so that's where that formula come in. It's a very easy formula for anybody to understand. So you can actually see that. So there was a 4 tree, those 3 spaces, 4 minus 1. That's where the n minus 1 comes in. And that's what the thinking skill that you have to all to think about when you deal with this. Yes.
So for the arithmetic series formula, how does that work when you have an odd number?
How do you have odd numbers? So it's like 1, 3, 5.
No. If you have like an odd number of numbers in a series.
Yeah, it still works. So let's just say if you want more, so let's just add one more term here. -3 subtract 4 is -7, right? It's this odd number, right? So then it's still this 9 plus -7 over 9 plus 7 times by 5 over 2, right? So that's equal to 5 over 2 times 2. That's equal to 5. If you add those 5 terms together, what you're gonna get? 5. So even the odd term will work. So that kid is pretty damn smart. Patrick Gauss, you should know that in physics, he's actually have a Gauss's law, which is the diameter of the circuit I don't know, I think conduct how much.
It's Q enclosed over epsilon naught is the flux of it.
I have no idea what you're talking about, but yeah. Yeah, Tyson's flexing right now. Tyson is flexing. Tyson's a Tyson's a flexing the flex formula. Huh? You know what? At least I have the guts to say it. You don't. All right, so today, telescope. Yesterday we talked about telescope series. Telescope series was different. So your answer for that particular one, you should do decompositions. Huh? Yeah, I'm gonna do geometric, but I'm just telling you, if you did it right, and if you think I'm bored for the next 2 minutes, at least the answer is 1. So you can go back and figure out why is 1. It's basically you decompose that, and you're gonna go to that. So we're gonna talk about geometric. Yeah, we're gonna talk about geometric. Geometric sequence, right? So you're gonna say, well, what is geometric sequence? Geometric sequence is like I don't know, if you have some type of bacteria that's growing double each time, so you got 1, 2, 4, 8, 16, blah 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 blah, and that is geometric sequence. Now its formula said there was a geometric series, so geometric series is gonna be 1 plus 2 plus 4 plus 8 plus 16. There's actually a very famous story about a king that who
Rice and chessboard.
yeah, rice and chessboard. Thank you. How do you know this shit?
Like, do you want this much or do you want to double it every day? And he's like, I want to double it every day. And it comes to the point when he could literally not afford to give him as much rice.
So so Samuel like kind of read my mind today about what I'm gonna say. But thank you. Yes, so it's rice and chessboard. But do you know what happened to that guy? He died. Yes. You guys that chop up. Okay, so basically, they are yeah, I don't need it. Yeah. Okay, so yeah, the checkerbox story is the king wanted them to invent a game because he's bored. So so he said, whoever invent the game, I will give you the prize that you asked for. So he could have asked married to his daughter, but he's stupid. He's trying to be like outsmart the king. So he asked the king, says, I want a checkerbox. I invent this game. It's called chess, and then I want you put the first piece rice on the first square, and the second one I want to double it. I want you to double each time, and I want all this rice in combined. And then end up it was like a national gross, like United States, like huh?
It was something ridiculous, like you would have to bury the entire earth in rice.
Yeah. And then something like it's the king went back because he went to the treasurer. It's like, how come you still didn't reward this man yet? And treasurer's like, I'm still calculating. And so it's not just only like 2 to the 64 powered, it's all the terms adding prior. So even it's 2 to the 64 plus 2 to the 63 plus 2 to the actually 63 or 65
minus 1.
yeah, so it's gonna be a lot of information, add a lot of rice add together. So it's adding every single square, not just only in the last square is the most amazing big number. It's adding all the squares. Zach, I cannot talk over you. I'm start losing my voice. So that's geometric series. Now, most of you guys gonna think about geometric series is always diverge. That's not entirely true because not going to diverge. There is a there's condition why they are diverge and converge. Can you explain me why they are converge and why they are diverge and what is a good indication? Yes.
It's in the denominator.
So before that, I explain that there is actually something I need to explain to you. So in arithmetic, there's a common difference. How about geometric? What do they have a common what? Common ratio. Thank you. So that's going to be common ratio. So what is common ratio? Common ratio is going to be this. Okay, common ratio is this. So it's going to be always the prior term divided by this. So the higher terms on the top and the lower term on the bottom. That's called common ratio. Now, it reminded me of yesterday. I was helping a student, and then she sent me this question. I thought it was really cool questions, but I don't know if I can find it. Now it's on my WeChat. So if you guys are smart, you want to figure out what will be the sequence. This is a series. This is a geometric series. It's k minus 1, 2k, and 21 minus k. So you want to figure out what k is, and it's going to form a geometric series. So this is the question. I thought this is kind of cool questions, and you want to find out the value k. So if you guys want to have fun, you can go figure out this k. So anyway, this is the question. Okay, let's see if you guys can find out a k. I think maybe some of you guys can figure out a k.
Are they all equal or?
They are geometric sequence.
Okay, constant.
K is a constant.
Zoom in a little bit.
This is algebra 2 question. And that was a pretty cool question. I was like, oh, okay, that's cool. You got it? Shira, you got 30 seconds to solve this problem.
I'm watching your other video.
What?
I need to do that lesson first.
No, you can do this one first. That one you can. It's always going to be there. It's a geometric sequence. So can you figure out what k is?
What are we learning?
Josh, you already found it?
Yeah.
That was very fast. He beat you. He should be on the math team. Not complete.
What are we doing?
You want to figure out a k.
What for what?
You figure out. It's a geometric sequence. Language is the minor in the room. No more cursing for you.
You could use
It's a really simple algebra question. You got the same answer to him, but it's incomplete. There's more than one answer.
Is it 7/5 also?
That's actually pretty good. Good job.
Oh, please. I did.
Samuel, why don't Samuel? You want to go do math competition on the Orlando Science?
No.
Come on. Your mom would be proud of you. It's actually pretty good. Huh?
What's the third one?
21 minus k.
On the common ratio.
Oh, so a3 divided by it's just a prior term, the next term over the prior term. So like a3 over a2, a5 over a4, they are supposed to equal to each other.
We use that for the plus.
I guess, I don't know. You guys are weak.
Using the entire time. Yeah, I hope so.
Yeah, I know.
Oh my gosh.
Oh wow, good job.
Yup.
You don't need to do quadratic, you can factor it.
No, but I want to make it hard.
Okay, y'all kind of weak, but anyway, I'm keep on going. The answer is you still haven't solved yet?
I'm taking my time to enjoy.
Slow poll. Well, I'm gonna take Samuel over you. He knew how to factor. Judah, Will is asking how to factor. All right, so I'm moving.
No.
Oh, I'm actually an idiot.
Y'all are idiot.
That's been my rule literally.
22 minutes, you guys cannot figure out. I'm moving on. K equal to 3 and 7 over 5. Alright. Alright, so there is an equation for geometric series. You might want to write this down. This is a geometric series for the things, but this is not the one I'm asking because this is actually gonna give you a partial sum. So for example, this you could plug in here, you're gonna get the right answer if you're using this formula. So you might want to know this formula. This formula is called geometric series formula. Yeah, but A is a first term. Oh yeah, A1 is a first term times 1 minus R to the n over 1 minus R. R is a common ratio. So this is a common ratio because they all have the same ratio that here is 2, right? So we can try to plug in here. So this is the first term. 1 minus, the ratio is 2, right? And 1 minus 2 to which power? That's a first 4 term. So it'll be 4. So that's equal to negative 1. 1 times negative 15, I think. So it's 15. So the first 4 terms should be 15. Is that right? Yeah, I was right. I'm a genius.
How do you know the ratio is 2?
2 divided by 1. 4 divided by 2. 8 divided by 4.
Oh.
Yeah, I'm using this information right here. Okay. So now, can you tell me what is deciding? Are they converge or diverge? What is deciding converge or diverge, and how are they deciding? I know you know because I teach you yesterday. What is converge and what is diverge? A geometric series. What's deciding it? What's the most important thing that's deciding the converge or diverge? Yes. R is less than 1, but actually it's even more precise. It's actually absolute value of R. So geometric series is converge only if absolute value R is less than 1. Absolute value R. Because R could be negative half, that's still a converge. But what if it's negative 2? Then that's diverge, right? So the R has to be less than 1, but it's not R, it's absolute value R. But what if R is equal to 1? Are they converge or diverge? But it's still adding all the term though, so it is diverge. Okay, so it has to be less than 1. So this R has to be less than 1 in order to converge. Now, it turns out this is the partial sum, right? Now, can I get a sum of infinite? So there is an equation for sum of infinite. So let me show you geometric form. Geometric series is going to look like this. N equal to 0, infinity of a to the r to the n. This is what geometric series look like. So first term is going to be a, and the second term is going to multiply by the ratio. So like say 1 times 2, right? So it'll be a times r plus a times r squared plus a times r to the third dot 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 plus a to the r to the n. Does that make sense? Because I just multiply by r each time. Like 1 times 2 is 2, 2 times 2 is equal to 4, 4 times 2 is 8, and so on and so on. You multiply by that 2. Yes.
This is kind of a dumb question, but is E a geometric sequence technically? Yeah, thanks, RP. Thanks, bro.
1 plus 1 over x to the x power is the definition of E. But it not really, because inside is still adding, right? Still adding 1 over x each time. So the definition E is, it might not be a dumb question, it might be you are too smart for me, but I can answer you right now. I don't think so though.
Yeah.
But I could be wrong. I could be wrong, but I don't think so. No, it's not a dumb question. There's no dumb question. Oh, the formula is this formula. So if R is less than 1, absolute value R is less than 1, then is converge. But what do they converge to? That's the question. So it turns out in algebra 2, you also learn something called infinite geometric series. So what is infinite geometric series? So if something is infinite, so we're gonna say this is n equal to 0, infinity a to the r to the n, and that's equal to this easy formula. Trust me, if any formula you need to memorize, this is your best friend. I'm speaking of this is your best friend. It's a over 1 minus r. Only in condition is absolute value r is less than 1. So this is the most important thing there is. Yes.
In the E thing, Wait, is that A? Why is in the end?
What are you talking about? E.
Wait, A, R, and
A to the R n. This one. This is called geometric series. It's just the first term times ratio, ratio to the second, ratio to the third, ratio to the fourth, common ratio.
Wait, is that A of 0?
A of no, it's A of 1. All right, so shh. Remember yesterday we have this, right? 1/2 plus 1/4 plus 1/8 plus 1/6 and then 16. This one's going. So how do I find out if they're infinite? Yesterday we did a different way. Yesterday we figured out what is S1 is equal to 1/2. S2 is equal to 3/4. S3 is equal to what? 7/8. And S4 is equal to 15/16. And eventually we say Sn equal to 2 to the n minus 1/2 to the n. And we decide to reach that infinity. If I reach infinity, then it's going to be 2n minus 1/2n. Then that's equal to 1. So eventually equal to 1. Now today I can use this cool formula that we just learned. It's called infinite series. They will work on any series if r is less than 1. Absolute value r is less than 1. So if I start with first term is 1/2, 1 minus r, 1/2 divided by 1/2, that's equal to 1. Beautiful equation. Very, very beautiful equation. It will work on all situations if it's geometric series and if it's r is less than 1. No, absolute value r is less than 1. Always working. Very simple equation. You just have to figure out how to do it. Got it? Okay. So today we're going to show you this equation here. We said, hey, can you figure out this? Okay. First of all, I want you to give it a try first before I go over it. What?
What is R?
R is the common ratio. Today's homework gonna have telescoping. Telescope series, not telescoping. Telescope. I changed it to a verb. English doesn't apply to me.
That's why I kept laughing.
All right, so if you really have an issue, you want to break down to this format right here. How do I break that format? That's equal to summation of n equal to 0 to infinity. And can I just say 3 is right here? And can I just say that's 1/2 to the n? Do I change anything? That 3 is a constant. I move it aside. But now I can decide, because that 3/2, you thought that was a common ratio. But it's not really 3 is a common ratio because only 2 to the n, not 3 to the n. If it's 3 to the n, then it's 3/2 to the n. Then the common ratio is 3/2. But in this particular case, the common ratio is what? 1/2. Now, what's the difference between this one and prior one? Because if you write out a couple of terms, you'll see it. The first term is going to be 3 times 1/2, right? No, sorry, 3 times 1. My bad. 3 times 1, right? Because n equals r equal to 0. Because it's always equal to 0 here. So 3 times 1/2 plus 3 times 1/2 to the square plus 3 to the 1/2 to the third. And dot, 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 dot. But then we can use a formula now. A over 1 minus r. What is A? 3. What is 1 minus r? So that's equal to 6. All right, n equal to 0, infinity, let's say 3 over 2n. What do you think this one is? Very, very easy.
Oh. Yeah, okay, it's 2 over 3.
Nope.
Let's go. Wait, no. I'm done. I'm dumb. It is not working. It is divergent.
Keyword is one word.
It's like the book.
What word? Oh, okay.
One word. Isn't it a number?
No, it's not a number, dumb. It's not a number.
What are we looking for?
We're looking for the series.
Diverge. What do you?
Okay, so one of the homework question that's a little bit hard, you want to think about this as well. So e to the n over 3 to the n plus 1. So you want to think about this.
Oh yeah, you have the
He's like constantly.
I'll send you an email.
What?
I really just got started on stuff like that. Yes. My one of the bigger ones I remember is a book called The Man Who Found It, about a dude traveling with another dude in India.
Actually, can I get a book?
I can probably bring you it.
Yeah, I'll. It's like the topic of the math.
Yeah.
I'll actually.
One in it, a couple other fun ones in it.
Okay, so I'm talking to a girl who wants to study Chinese school. And she says,
No, you don't have to write it.
you'd be like,
No. Tell me English. What's the script in English?
so you want the script in English, and then you just.
I'll translate it.
Are you sure?
Yeah.
Oh,
I'll translate myself. I'm Chinese.
do whatever.
I just cannot talk to a white people. And you know how like you cannot speak a white person from Korean.
Yeah.
Your brain kind of like, man, she's white. I cannot speak Korean. It's like you have to have like
Like I can only talk to funny people. Oh, so that's a really good joke. Oh, okay. Look. Okay.
Tell me the joke.
Calendars. Who uses calendars? Calendars are for the week.
Speaking of whatever.
First term,
Yes,
so you put them on E over 3 squared, so it's E over 9.
Figure out what a common ratio is.
Oh, and you can do, but then with N.
Wait, so you do like the first one, the second one, you compare them? The differences?
No, if you just like change the to e to the n times 3 times 3 to the n, right? Now you can factor out 1/3 out. Then it will be e to the n over 3 to the n.
That goes like E to the N times 3 N to the.
Okay, so yes, it's just math. It's just math manipulation. So what was the question? Summation what? N equal to 1,
Infinity, E to the N over E to the N plus 1.
3 to the n plus 1, right? So once you figure out the first term, it's gonna be e over what? 9. Okay, so good. So that's your a, right? Now you just have to figure out r. So you can rewrite this n equal to 1 infinity. That is going to be 1 over 3rd e to the n over 3 to the n, right? Because this
Yeah.
3 times that, right? It's just a simple rules.
Yeah.
That's equal to summation of n equal to 1 infinity 1/3 times e over 3 to the n. So this is the r.
That's R.
Okay, okay.
So now you just do a, which is e over 9,
Yeah.
divided by 1 minus e over 3.
E over 3, that's less than 1.
I get that though.
Yeah, e over 3 is less than 1, so that was kind of tricky, right?
Yeah, I was tricky because the N plus 1 thing is like.
Alright, we got.
Yeah. The one above that is.
What'd you say? What?